The tragedy of the commons is a socioeconomic phenomena that occurs when a group of individuals have shared access to a common resource. Say, for example, we're all farmers with access to shared grazing land here on campus. Now, if we all follow the spirit of the law and use just our fair share, we all get to reap the benefits of this additional land. However, suppose I, being the self-interested farmer that I am, decide to exploit this resource and graze beyond my allocation. This can lead to the land being overgrazed and spoiling it for everyone. Now, my research focuses on the design and controls of wind turbine arrays. Wind turbines generate power based on two key factors: the average incoming wind velocity and how fast the turbine blades spin. Inside, there's a small computer that measures the incoming wind speed and tells the turbine to spin at a specific operating torque. These computers are very well optimized to maximize the power of any single individual given turbine. Now you may ask why I started by talking about the tragedy of the commons. On a gusty day, there's certainly plenty of wind to go around. However, access to an undisturbed wind becomes the common resource. See, as wind passes through a wind turbine, it generates a turbulence field. You can see that at the image at the right. This turbulence field leads to a lower average wind velocity and thus less available power. This means turbines at the front of a wind farm, acting optimally to extract as much power as they themselves can, will actually lead to power losses for the remainder of the farm. This is what I like to call the tragedy of the wind turbines. Now, my research focuses on two different ways to get wind turbines to work together collectively. The first is that of an external controller. By having this controller have access to all wind turbine measurement data, one can manually reallocate a different set of operating torques and thus help mitigate this turbine-to-turbine interference. My research has shown that this control design can improve power of the wind farm by as much as 6%. With wind energy being one of the most promising energy sources in a green world, every optimization matters. The other is known as wake steering. It turns out by intentionally misaligning front turbines, you can bend this deflection field. You see that the orange wake is avoiding downstream turbines. This can lead to greater power for downstream turbines and thus more for the whole farm. These two are some of the most cutting-edge techniques that can be used to improve wind turbine energy output today. Thank you.